and welcome to the system demonstration for our web-based platform for iterative planning with plan explanations. In many real-life scenarios, not all goals, constraints and preferences are all given from the beginning. Therefore, the traditional planning setting, where the planner computes only one plan, is not applicable. Instead, planning as an iterative process is more suitable. This allows the human user to iteratively refine their preferences and goals based on the sample plans. Furthermore, the possibility to provide explanations answering user questions about the current plan is a key feature in this setting. In the following, we present a web-based platform which allows iterative planning with explanations. The key feature our system provides are performing iterative planning, where the plan properties represent goals and preferences. Changing preferences are reflected by enforcing plan properties across planning iterations. You can ask questions about the iterative refined plans. You can also add new plan properties to in on new issues that become apparent during the iterative planning process. To accommodate layperson, we provide a simplified version with fixed set of plan properties and an enriched visualization of the planning task. Our tool also supports user studies. It provides interfaces for user study developers and test persons. This is our running example. We have a small village with 3 houses, a post office, a packing station and a coffee shop. There are 2 trucks with a limited amount of fuel which must deliver up to 5 packages. The plan properties we consider besides delivering packages are, for example, visiting certain locations or delivering 2 packages with the same truck. So let's start iterative planning. Here we have a plan where all packages are delivered. If you take a look at the not satisfied soft goals, you can see that the blue truck does not visit the cafe. But the driver of the blue truck cannot live without his coffee. So the question is, why does the blue truck not visit the cafe? And the answer, there exists a plan where all packages are delivered and the driver gets his coffee. So let's add the blue truck visits the cafe to the hard goals in the next iteration. Fast forward and we get a new plan. Now let's take a look at the animation. As you might have noticed, the red truck uses the road between the cafe and the packing station. But this is a very busy road and we want to avoid it. So let's find out why the busy road is used. The answer to our question is given as subsets of the hard goals which can no longer be satisfied if we enforce to not use the road. Here the answer is, if you do not use the road between the cafe and the packing station, then you cannot deliver package 1 and 4. Next, let's take a look at a set of hard goals which is unsolvable. But now you might want to know, why is this selection of hard goals unsolvable? The answer to this question is given as all minimal unsolvable subsets of the selected hard goals. Here, the selection of hard goals is unsolvable because you cannot deliver package 2 and use the same truck for package 0 and 2. Next up is how you can create an iterative planning project, compute a demo, and set up a user study. A project is the base component in our tool. It is based on a PDDL domain and problem file. Additionally, there is a domain specification which defines domain-dependent visualization features and plan property templates. To simplify the definition of plan properties, you can use one of these predefined templates which maps a natural language phrase to an LTL formula. Here we have the template, the road between location X and Y is used with truck T. The template definition also includes constraints between the variables, like the 2 locations have to be connected. In the expert view, it is also possible to define plan properties with LTL formulas over facts and actions. The option to add new plan properties involves an online computation of the explanation. This is not always necessary or even possible, for example in a user study. Therefore, we include the function of computing a demo. A demo is based on a project and has a fixed set of plan properties which allows to pre-compute all explanations. Our platform can also be used to conduct online user studies. User studies can consist of additional descriptions, links to external questionnaire sites, and multiple demos. Additionally, a demo provides more settings like the restriction of time or iterations, the maximal size of questions, or the use of a utility. The data collected in a user study, like number of iterations and questions, or the time spent with each component of the interface, can also be visualized. Thank you for watching. If you like our work, please vote for us as best system demonstration. Have a nice ICAPS!